going over melting point and boiling point temperatures. So the melting point is simply the temperature in which a substance changes between the solid and liquid phase. And when a solid is changing to a liquid or a liquid is changing back to a solid, the temperature of that sample remains constant, meaning that the temperature does not go up or down during the phase change. The melting point is also the sample's or the substance's freezing point. So the temperature which a solid melts into a liquid, or the temperature the liquid freezes back into the solid, those two temperatures are at the exact same value. The boiling point is the temperature in which a substance changes between the liquid phase and the gas phase. And once again, while a sample of liquid is changing to a gas or a gas condensing back to a liquid, the temperature of the sample remains absolutely constant. The temperature does not increase or decrease during the phase change. The boiling point is also known as the condensing point. So boiling point and condensing point are the exact same temperature. Okay, so we need to take a look at Table S, and here in the notebook I have just a small selection of Table S. So if you have your reference table, Table S, I would make these notes right in the reference table so that you have it there every time you open it up. But the first thing is the melting point. I would make a note that the melting point is also the freezing point. So here's the trick question: is it will ask you what is an element's freezing point. But when you look at Table S, you are given the melting points, and if you made the connection that the melting point is the same temperature as the freezing point, then it doesn't matter whether you're asked what the melting point or the freezing point is, because it's the exact same temperature. The same thing is true is if you know the boiling point of an element listed on Table S, then you also know its condensing point. So make the connection: boiling and condensing are the same temperature, melting and freezing occur at the same temperature. Also, when a material is at its melting point, that means that we see both phases present. Solid is changing into a liquid, or the liquid is changing back into a solid. So we see both the solid and liquid phase present. And at the boiling point, we have anything that's in the liquid state is starting to change into a gas, but if it's already gas, then it's returning to the liquid state. So if we hold a sample at its boiling point, both phases of the matter will be present. Now, using the information on Table S, you will see the element's atomic number and the element's symbol and the element's name way over on the left-hand side. And then further to the right, you'll see a column known as the melting point and another one as boiling point. So the melting point is when we see a solid and liquid both present. But if the temperature that our element is being held at is a temperature less than the melting point value, so if the temperature is less, then our sample is going to be completely in the solid state. If the temperature that we're holding our sample at is a greater temperature than the boiling point listed for that element, then our sample is going to be in the gas or vapor state. Now, if our temperature that we're holding our sample at is a higher temperature than the listed melting point, but it is less than the boiling point temperature. So the temperature we're holding the sample at is somewhere between the melting and the boiling point, then our sample is in the liquid phase. So let's take a look at a couple of examples of using table S. Move it up just a little bit higher. Okay, so take a look. I have the element Na sodium, number 11. So I would go find number 11 on table S. I'll see Na, and I take a look at its melting point value. And 273 is the temperature I'm holding the Na at, and 273 is a temperature less than Na's melting point. So the temperature I'm holding the sodium at is less than its melting point. So sodium, I would expect it to be a solid. Okay, going down to the we do right underneath. Now I'm looking at the element Cl, chlorine, number 17 on the list, and I'm holding a sample of chlorine at 273. The temperature 273, it's actually higher than chlorine's melting point, and 273 is also higher or a greater temperature than chlorine's boiling point. And because 273 is greater than its boiling point, at 273 kelvins, I would expect chlorine to be in the gas phase. Moving over to the other I do, scandium. So scandium is being held at a temperature of 1,544, but I have to pay attention to the units. So here, the unit is in degrees Celsius. And when we look at table S, the melting and boiling points are in Kelvin. So I need to first change 1,544 into kelvins, so then I can compare that temperature to scandium's melting and boiling point. So I add 273 to 1,544, and that's 1,817 kelvins. So I compare the Kelvin temperature to table S. So looking at scandium, 1,817 kelvins, it is greater than scandium's melting point. But 1,817, that temperature is less than scandium's boiling point. So 1,817 kelvins is a temperature that falls between the melting and the boiling. So I would expect the scandium to be in the liquid phase. Last example here is the bromine, and the bromine, once again, is being held at 9 degrees and it's in Celsius. So I have to change the Celsius temperature to Kelvin to compare it to the table S melting and boiling points. So when I add 273 to -9, I end up with a temperature of 264 kelvins. So I need to compare the Kelvin temperature to bromine's melting and boiling point. And so 264, it happens to be less than Br or bromine's melting point. So since 264 is a lower temperature than when it melts, I would expect the bromine to be in the solid phase. So you try the UDO number 1 and UDO number 2 and check your answers with your teacher.